Hi, welcome back to the series. My name's Andy. We are implementing a miniature Rust in Rust. We have really not got far, but we have got awesome error messages. Look what happens when we pass in something that it doesn't know how to lex. It prints out a thing saying, look, this character along here is wrong, and here's a little snippet of your source code. That's thanks to the Miette library that we're using. Anyway, where we've got to is we've got what's probably a reasonable structure for lexing, which is we take in a str, so we basically get in the whole contents of a file, and that's needed really to give us those nice error messages. So we're okay with not taking in like an iterable of characters or something like that. We do then immediately break it into an iterable of characters. But we're returning an iterator from here, which I think is the right structure. So that a lexer just is like an iterator over the tokens that we found. But we're undermining that process. We do return an iterator, but we actually build that iterator by just making a vector and returning that at the end. So we're not actually saving the memory that we should be saving by providing tokens one by one. Instead, we're putting them all into a vector and returning them. And that was just a shortcut we took. So before we get on to lexing more stuff, we're going to try and fix that shortcut by instead of collecting things to a vector, having a struct called something like capital L lex. Let's call it that for now. Which implements iterator like this, and it's going to implement an iterator with an item type of Miette result of token, where token is our lexing class and Miette result is just the fact that you might fail in the middle of lexing. So you have to keep providing things, and one of them might be an error. And then we've got a next method, and all of the stuff we've been doing in here is going to go into our next method. So instead of a while loop, it's going to be, we're going to construct a lex here and pass in input. And when we pass that in, we're going to do this wrapping it up in a byte chart. So let's make a constructor for lex. Import lex fun new takes in a str, and it wraps that up, so it returns a self, and self is going to hold on to not the str, but the character iterator over it. So that means we need here, this is going to have input. No, it's not. Sorry, it's not that. It's a byte chars, isn't it? Because it's our class that we made last video. Byte chars of input. Now, a byte chars holds onto a reference, so it needs a lifetime, which means that this struct also needs a lifetime, like so. And that means we need a lifetime on this, like this, and that means in order for all this to work, the string you pass in has to have that same lifetime that you're going to return here. And now we also need lifetimes on this thing. So every time you make an iterator, well, every time you do anything with lex, you need to know what lifetime, what the lifetime of the thing it's referring to is. All right, so now we have this input thing inside self. Now we can start iterating through it in next. So instead of creating a vector, and then having a while loop and collecting everything into the vector, what we're actually going to do is just get one thing, because we've been asked for our next thing, so we just need to provide you with one token. Now, obviously, one token might take more than one char, but okay, that looks okay. Okay, we need some way of exposing a lifetime here. So what we can do is just say we return a lex. And then the lifetime is explicit. Like so. And I think we're okay. Yeah, so it turns out, I mean, Lex does implement iterator, but we need to be explicit about what we're returning from here. All right, so back into Lex, and let's see how this looks. So we are going to, oh, this is our input, isn't it? Or maybe we should call it chars. What should we call it? I guess it's just an iterator over our input, so calling it input is okay. And now we've got various places we do stuff with chars. So here, this is going to be self.input.bytes, which is straightforward. Now we're missing something. We need not just chars, but also, all right, so I'm changed my mind. We're going back to calling it chars because we're going to need to hold on to the actual original string as well. Now, is this going to give us a lifetime problem? Let's find out. Oh, come on. So we're going to make chars as this. Maybe we make it. Oh, okay, it's allowing us to do that. Fine. Right, we won't worry about it. It just, like, lifetimes are clever enough, I guess. So now we have to refer to self.chars here and here and self.input here. So the reason why we're holding on to chars as well as input is that when we make our pretty error message, we actually use the full string of our input that we were given. And most of the time, we're just dealing with the iterator over the characters that we've got here. And in this case, this is telling us how far through that string we got in order to print that error. Now, we have got some things here. So, all right, so first of all, we've got this was error thing we need to deal with. And secondly, we've got this. So this is easy. This is just going to be, we're going to return toc. And in this was error business, we can't break out of a loop because we're not in a loop. What we need to do is remember that next time you call next, should be some toc, right? Otherwise, we're going to return none. So if we hit an error case, the next time someone calls next, we should return that error. No, we should stop. We should have stopped iterating because we returned an error. And this should, well, for now, we'll pass in self.chars, but soon it's soon going to become a method on this object, I think. But not yet. All right, so for now, let's not implement this was error business. And I reckon we haven't got a test for it, so we need to write a test for it if so. Yeah, oh dear. So we managed to write some code before that wasn't properly tested. So now we're going to test it. So the situation here is that there's an error, and then we want you to stop producing tokens. But at the moment, I think we'll continue. So let's just have a test like we stop producing. I mean, maybe we don't want this, but generally, once you've gone wrong in the lexer, who knows what you're going to lex next? Like maybe, the rest of the source code was inside a string or something because there's a missing double quote or something like that. So we start producing tokens when there is an error. So we'll have a couple of tokens, and then we'll have something we can't parse, and then a couple more tokens. And it should come out as just, well, we can't use lex v. We have to use lex. And then we're going to collect it into, we're going to collect into a vec of result. And so these are going to be okay, like this. But also there's going to be an error in here, and it's going to be it's going to be some kind of miette error, isn't it? I think. Let's see. It's going to tell us. Let's just say, imagine for a second it's an E32 error type. It obviously isn't. No, it doesn't like that. What about string? It's printed. All right. Yeah, of course. Yeah. I'm being silly. So yeah, the type is a result of error report. So this is awkward, isn't it? All I really need to check is that the length of it is 3. So maybe we can just count and say there should only be 3 of them. And then we don't have to worry about what the type of that thing is, right? So that should fail at the moment, because at the moment we carry on producing tokens after we got an error. So let's now think about this was error thing. So what we need to say is, inside Lex, we need to remember that we hit an error, like so. And that means we'll return the error. So we actually returned something the first time we set hit error. But next time, if we've hit an error, we just immediately return none, right? Because we don't want to return tokens after we've hit an error. That's exactly the thing. So then here we want to just say, if this was an error, then self.hitError is true. And we don't even need an else case. And then we return token. So we return token anyway, but first of all, we just remember that it was an error. And now our test pass. Oh, fantastic. All right, so where were we? Oh yeah, okay. All right, so we've done it. So I kind of rushed through it because I was thinking we were going to hit problems and I was going to need to explain them, but it looks like it's working. So what we've done is, instead of implementing a while loop inside this lex function, collecting all the answers into a vector and then returning vector.intoIter to get our iterator. Now we're doing it properly. We've implemented this thing called lex, which itself is an iterator. And then in the next method of that iterator, we're checking we're not already finished because we hit an error, in which case we return none. Otherwise, get the next character, check what it is, and if it's an int, then go into the int code where we pull out more characters. Once we've finished with that, we get back either a token or an error. That's what toc is. Just remember whether it's an error and then return that token. So we're only returning that one token. So we're not using so much memory. If we're producing huge numbers of tokens, we won't be using so much memory, but also just on principle, it feels right that a lexer produces tokens one at a time and doesn't just create this massive vec of all the answers, even though we are holding on to this potentially massive string, which is the file that we're reading. But I think that's okay. That will be compact, whereas these tokens might be a bit more bloated with more information. And it feels right, All right, so one last thing we're going to do in this video is we're going to change the way int works. Currently int is a free function, but I think it should be a method on this lex object, and we wouldn't have to pass in self.charts. It would be better. And also, just I think for niceness, I think the actual implementation of iterator should be small, and all the real work should be done inside the main lex thing. So we're going to make a function like, what are we going to call this? Lex next, maybe. Something that just is pretty meaningless, that does all the work that's currently done in next. So it's going to return an option of self item, and self item is, of course, oh, hold on. Self item is defined in here. So I guess it's going to be, we have to actually say what it returns, I think. I mean, we could define another item, I guess, but that feels potentially confusing. And we're going to do all the work in here. And just call it from next. The reason I'm doing that is just because I'm about to put some more code in self.next, lex next. I'm about to put some more code in this thing, and it just feels right for it to be next door. So let's check that still works. Still works. All right. So in the int function, int method, which we're calling here, is going to move in and go at the bottom here. Here, no, here. And it's going to take, instead of taking in chars, it's going to take in a mutable reference to self. And then do something with self.chars here. And when we call it, we're going to call it as self.int and pass in that char. By the way, not particularly happy about passing in this like partially created. No, or we might have to live with it. But anyway, at the moment we're passing in the first character that makes up this int, and then using it to construct a string, which we then construct more of as we go through the int. So that should still work. It does. All right. So we have refactored our lex function so that it uses, where are we? So that it's a real iterator that has a next method that calls lex next, and lex next just pulls out as many characters as it needs to create one token, and then it returns that token. I think the next thing on our list is being able to lex just enough stuff that we can start implementing a parser, which does something interesting, and then an evaluator, which does something interesting. So I think what next time what we're going to do, apart from moving the lexer out into its own file, which we'll probably do, is lex one more thing, maybe a plus. So maybe we're going to be able to lex something like something like 2 plus 3. Once we can lex that, then that's probably worth passing on to a parser, because you can parse that and make an interesting tree structure of it. This is a plus with 2 arguments, or 2, yeah, what are they called? Anyway, 2 things passed into plus, a 2 and a 3. And of course, once you've got that, you can evaluate that and say, what's the answer to 2 plus 3? Wouldn't that be amazing? So yeah, I hope you're still enjoying it. Hope you're being kind to yourself and other people. Hope you're voting wherever you are, whatever election process you have available to you, if any. I hope you're voting in a kind way, kind to yourself and others. Very much enjoyed hanging out with you. Do leave comments. Let me know what I can do better, or what you enjoyed, or what fun things you'd like to look at next. And yeah, soon, maybe not next video, but maybe the one after, bit of parsing, bit of evaluating. See you then.